curriculum. So let me introduce myself. I am Dr. Prashant Bhatt. I completed my PhD from Manipal Institute of Technology in the year 2023. Later, I started working as a scientist in one semiconductor industry. There, I was in R&D department. We used to fabricate some components for space and defense applications. So here I would like to start physics. For you guys, I'm going to teach physics course. So I would like to start with a question. What is meant by physics? Any general definition can you give?
Everything under the universe.
Correct.
Interaction of matter and radiation.
Yeah, great. Yeah, that is the main basic sentence. We can call it as interaction of radiation with matter.
But we understand there is motion.
Yeah, there is different.
It doesn't seem to be coming as between matter and radiation.
Now, I'm trying to analyze that. So, based on this, we have designed your course in 3 modules. There is first interaction of matter between themselves. We can call it as statics and dynamics. And next one is interaction of matter with radiation, nothing but light. We can call it as optics. And combiningly, interaction of radiation again with matter, combined together, we can call it as electricity and magnetism. I hope you guys have learned basics about these modules, these concepts in your class 12. So based on that fundamentals, we have designed this course to help for your engineering specialization course. Considering all these modules, I am very good at in teaching as well as in research aspect. So this course is going to be a little bit different in such a way that correct. Called learner-centric outcome-based education. Learner-centric. Sorry, this board is not responding my speed. So we call it as LCOBE. So here your learning cycle will be, there will be content, and there will be worked examples, and there will be problem sets, and there will be formative assessment. So what is meant by content? Here I am going to teach in lab as well as classroom. I am going to explain some equations, laws. In lab, we are going to explain something about working principles. So these are all coming under content. Next come to worked examples. Based on my contents, what I have delivered in the class as well as lab, we are going to solve some examples Here I'll be solving some examples in stepwise. I'll explain each and every process in detail. Next come to problem sets. Based on my worked examples, I will be giving some problems for you guys to understand as well as to solve those kind of problems. So based on your problem solving capability, we'll be having some formative assessment. So if you are not understanding problems correctly, again, you need to go back to the content. You need to go back to the worked examples, problem sets that will complete your learning cycles. So next come to the course plan. Here, as I said beginning, we'll be having 3 modules, statics and dynamics. Optics and electricity and magnetism.
Little more visible reach.
Okay. Here in statics and dynamics, we are bifurcating in 2 parts. Initially, statics will be learning. That will cover in 5 initial 3 weeks. There will be 5 lectures. And for dynamics, there will be 10 lectures. Overall, 15 lectures will be there in statics and dynamics. So here in statics, you will be learning something related to the forces, moment of rotation, center of gravity, I can call it as CG, and some engineering structures. In dynamics, you will be learning something related to the acceleration, angular momentum, as well as some circular motion related concept. So this will be covering initial 5 weeks, total 15 lectures. And next module, that is called optics, will be having 15 lectures again. Here we'll learn something about reflection, basics, refraction, diffraction, interference, and some optoelectronic device concept. And their working principles. Likewise, in electricity and magnetism, we'll be learning something basics of charges, potentials, and in magnetic levitation and all. Also some problems related to the engineering things. So adding to these, we'll be having one reflection for every 3 weeks. What is meant by reflection? Anyone? Yeah, that is correct. What is meant by reflection? Like in Kannada, we can call it as pratibimba. In a sense, you have to reflect yourself. In a sense, again, you have to write your learning process. like what worked well and what didn't. Like while doing your problem solving, you may may go through some problems. Again, while solving some problems, you may go through some difficulties. So how did you like encounter those kind of difficulties while doing the problem solving? That is, that I'm expecting from you guys. Every 3 weeks, you have to submit 1-page reflection kind of things. So that will help me as well as you to understand the concept better. So once we come to the lab experiments, we'll be having 12 plus 3 experiments. So in these lab experiments, we are aligning your course, like theory classes as well as lab classes simultaneously. Simultaneously in the sense, your lab, like optics lab will go together during optic class, like that whatever the concept we are teaching in optic class, that will reflect in your like lab sessions. Likewise, we are planning. So total 15 lab sessions will be there. So based on this, I am expecting from you guys
Is 12 plus 3? Why not 15?
3 we have kept some extra, like if any thing, like any experiment is not going well, that we are planning for extra. So basically they have to complete 12 experiments. So theory classes, I am expecting for you all to attend this. There will be 3 classes per week. And laboratory, 1 session that will have 2 hours. And you have to complete your lab journals before coming to the lab. Journal writing, I am assigning for that 2 hours per week.
Can't they complete in that time? The experiment time they cannot complete.
No, sir, they cannot complete during that time. So next is problem set solving. So here I am planning to give 8 problems in every week. So each problem may take 30 minutes for you complete. And some physics club will be there. If you are interested, you can join. That may take 2 to 3 hours. And some tutorials also will be there. That may take 1 hour. And some revision session also will be there. That may take 2 to 3 hours. Overall, I am expecting 14 to 17 hours of your commitment for this course. Is that fair enough? Sorry? No, if you are interested, you can join. We are not forcing anyone to join this.
They have around 28 to 29 hours in sitting in classes.
Yeah.
40 hours.
No, these 2 are mandatory. Yeah.
Whole semester in a week, 40 hours.
Yeah.
In that 28 hours or 29 hours, they are sitting in classes. So remaining another 22. You are glad.
No, these are,
According to Shivdas research, they have to study 90 hours per
No, no, that is, no, no, I studied in the group, everything almost intellect.
Classroom only, right?
No.
Put it in classroom there, right?
No, no, so he takes like 5 hours, even then he is asking 8 or 9 hours on subject. So now 8 or
15 hours
9.
one subject. 90 hours, 15 hours one subject.
Yeah, and 6 subjects, 90 hours.
90 hours at home is different. This is all interactive. My issue is interactive issue.
Okay, let me
Yes,
do
you
that.
have to sit face to face.
After that,
I am also shooting.
no, these three are four are mandatory, sir. So these problem set solving and all, they can do it in their home. No issues. So next come to the reference book. So this is the book we are going to refer for all the modules. No, don't get scary. We are not going to read all entire book. Only few concepts we are going to read. It covers entire physics, like basics concepts of physics. So
It used to be so small when I studied it. This is that's one of the best. After holiday and this week, this is
It has progressed quite well. From your time. It has grown.
University of Physics by Young and Friedman. And Fundamentals of Physics, that also you can refer. By Halliday and Resnick. This is for statics and dynamics. For optics, along with University of Physics, you can refer one more book called Optics by Ajay Ghatak. Likewise, for electricity and magnetism, you can refer University of Physics and Introduction to Electrodynamics. By David J. Griffith. It has nice worked example, that is Introduction to Electrodynamics, but it requires some basic understanding of vector calculus, in-depth understanding of vector calculus. So you can refer for your understanding. Otherwise, you can refer University of Physics. So why these books we are going to refer? Because these are all globally recognized book. Also, these books are targeting some engineering related problems. Okay. I hope I have given enough outline about the course. Again, the course is Engineering Physics 1. So in that engineering physics, we are going to have engineering mechanics, what is meant by engineering mechanics? Anyone?
Analyzing forces, instructors.
Correct. So imagine you are entering a city, you will see lot of buildings, bridges, some cranes lifting heavy load to great extent of height. So even though these structures appear to be stationary, but there will be constant force acting on it and make it stationary. So to study that, we need to have an idea about engineering mechanics. By definition, it is a branch of science that studies effect of force acting on bodies at rest or in motion. So mathematically, it is, you know this formula, right? F equal to ma. This is the Newton's second law. F is nothing but resultant force. Force in Newton. M equal to mass. It is or kg or gram. And acceleration in meter per second square.
Sorry, sir, but when I learned it, they used to draw one arrows above the head of the thing. Why are we doing that? Okay.
Is that okay? Why we need to?
Why should we draw that arrow? That also I like it.
Yeah, it's a good question. I will explain. In couple of minutes, I will explain.
Okay, thank you.
Yeah. So when A becomes 0, so the resultant forces also will become 0, right? So that is nothing but a statics. So why do engineers study mechanics? Any answers? Why do we need to study engineering mechanics? Suppose Dr. Ramraj is going to build an aircraft. So first he need to understand what are the forces acting on airplane. It will act, some forces will act during flight. There is a lift, there is a thrust, there is a drag. If he understands these forces well enough, he can build a flight safely and nicely. So, like,
Continue.
yeah. So the classification of engineering mechanics, as I said, there will be engineering mechanics. Don't confuse, it is not electromagnetic wave. It's engineering mechanics. Initially, we'll be dealing with statics, and next we'll be dealing with dynamics. So what is meant by statics? Static is nothing but it's a branch of mechanics again that deals with the body at equilibrium. So here my resultant force along all the direction will become 0. So any examples for this statics?
Any object at rest.
Correct. So if I place a book on the table, why it is not falling through the table?
Because the forces are balanced.
Exactly. There are exactly correct. There are two kinds of forces acting on this book. One is normal force, another is its own weight. But in different direction, it is getting cancelled out, right? So that is nothing but the book is in static condition now. What is meant by dynamics? Dynamics undergo the body that undergo motion due to unbalanced force. Force, here my resultant force not equal to 0. An example for this dynamics, any moving object, right? Any moving object. So yeah.
Now, what happens if the it is in constant velocity.
Constant,
Velocity. Its force is zero.
yeah, force is zero. It's
So
the
its
kind of
dynamics are static.
constant velocity. It's again comes to different frame of reference, sir. That
I'm really answering. I don't understand that. Force is zero, so it is static object or it is dynamic.
I am not getting, sir. Like,
Suppose it is in constant velocity,
huh.
resultant force is zero, so it will not be dynamic.
So there are two kinds of equilibrium.
Yeah.
One is the static equilibrium.
Yeah.
And this is what is referred to as dynamic equilibrium.
Dynamic equilibrium. Okay. Yeah. Okay. Thank you.
No, that means dynamics is not about unbalanced forces in the object. Can be zero, but there is acceleration is zero, it's possible.
Yeah. Correct. Yeah, I agree. I agree.
It's not an if and only if condition.
Huh.
It's a if condition.
Correct. Correct.
No, I think there's a point here. I think if
Yeah, understood.
On the other side, if there is a constant velocity condition, how this one, is it considered a static problem or a dynamic problem?
Yeah.
That's the question.
Yes.
Yeah,
Correct.
You consider it a static problem?
No,
a
it's
constant motion.
constant motion. Dynamic equilibrium, we can call it as.
It's a dynamic problem.
Yeah, dynamic problem. Yeah, very good question. Thank you. So next come to force. So what is meant by force? Any definition? Some vague definition you can give? Yes, exactly.
No, serious question, it actually is also a question, there are no serious answers according to me. You may not be able to define force unless you.
What is
talk about
force?
acceleration.
We can define it as,
Because it's called cause.
yeah,
So cause is not, it's a major problem with cause, what causes motion.
a force is external push or pull acting on a body that tends to change its state of rest or uniform motion and its direction. It can cause some deformation also.
But it's only a circular, it's like push and pull. What is push and pull? It's like they circles, right?
Yeah.
I think it's
Yeah, don't get into force. That's okay.
No, Newton's laws is about defining what force is.
Yeah.
It's not a philosophical question.
Yeah, the rate of change of momentum is force.
But then you have to decide what is acceleration, what
No, you don't have to. Basically, change in state of motion
Yeah.
or deforming a body, the agency which does is called a force.
Yeah.
Defined clearly with clarity.
Yeah.
Newton's laws.
Philosophy you can. Yeah.
you can't separate. It's a reflection. So what causes is what
Yeah, it's an agency which causes.
So initially, he started like why there is no arrow mark in F, right? It's a vector quantity. Unlike mass and temperature, force cannot be defined in only in magnitude. It has some direction also, right? So imagine you are pushing a table in one direction with 100 Newton and another person pushing the table in opposite direction with 100 Newton. But magnitude is same, but direction is different. So the equal and opposite forces will cancel out, that table will become stationary. So that made this force as a vector quantity. So there are different kinds of forces we are going to deal with called contact force and non-contact force. Contact force in the sense when two bodies are in contact, physical contact, we can call it as contact force, and non-contact force in the sense there is no contact between the bodies. So here there are different kinds of forces again, examples, normal force, Frictional force, exactly. Some tension in a rope. Some spring in a force, spring force. In non-contact force, gravitational force, magnetic force and electric force. So in this module, we are going to deal with contact forces. So we have to represent this force, right, in different coordinate system. So we call it as force representation. I think you might have already learned about these things, polar coordinates and Cartesian coordinates, in your bridge courses. So I will try to explain once again. There are two coordinates called polar and Cartesian coordinate. Anyone can tell what is meant by polar coordinate? Exactly. What is meant by Cartesian coordinate? Yeah, great. So here initially I will write in 2 dimension. This is my x-axis, this is my y-axis. So my resultant force, this direction, I can call it as theta.
But X and Y are supposed to be 90
Sorry?
degree.
No, you can take this table as example. There is a x and y direction. It's a plane, just considering a plane. So likewise in 3 dimension, it's making phi theta. And this is the projection. So this is spherical coordinate we are defining in 3 dimension. Yeah, spherical polar coordinate. There are some other different coordinates also, like cylindrical coordinates also there. Yeah, we are dealing with spherical coordinates here. So
Sir, sorry, sir. What happened here? When you get the word R, which is R?
this is R. Yeah, in force we can define F also.
You are saying in both lines are R.
No, both lines. No, only this one. The resultant vector making the angle with Z is R. Here making with XY plane is called, you can call it as rho. I can call it as rho.
This is talking polar coordinates or spherical coordinates?
Spherical polar coordinates.
And that should, is it projection or is it projection?
So here I can okay, r comma theta, I can represent it. Here I can represent in r, theta and phi.
Sorry, sir. Can you explain what is theta and phi, sir?
Theta is like it's in XY plane R is making in Z direction. Sorry, phi is in Z direction. So this is my resultant force. So it is making, if you are considering this as a plane, so as a Z direction, it is making Z and X axis, that direction. That's a resultant force is theta.
So why do you need these? Why do you need this?
To understand the three-dimensional concept.
Okay, can't you do it in Cartesian coordinate?
Cartesian coordinate also we can consider, but we have to convert it. We can convert it
Why
for
so
simplicity.
Theta.
For simplicity.
Why we should convert?
It's a different kind of for simplicity only.
But
If you know anything better, you can. But there will be some projection, right? Even theta also that will rotate, no? If you are considering spherical way. So it is not sufficient. If it is any rotating problem and anything can rotate, so there will be some another direction, that theta and phi.
So you are trying to find the moment of inertia in sphere. It's much easier to work with spherical column.
It's like we have this meaning of relativity.
There
There are some problems where Cartesian coordinates are very related. So then it's
So in Cartesian problem again,
Always the ability to establish first.
I can write it as in fx and fy form. Again in polar, sorry. So, as I said beginning, we can convert one coordinate to another coordinate. That conversion will be in two dimension. F of x, I can write it as f of cos theta, and f of y, I can write it as f sin theta. Also, if I take, so that is nothing but f of y, fx. Also, my final magnitude of this force, I can write it as f of x square plus y square.
so it is fx is equal to x cos theta and y is equal to y.
So here the resultant force is making angle with x-axis.
But why can't you take f is equal to sin f sin theta? Fx is equal to x sin theta.
Now if you draw the triangle, it is very easier to check the adjacent and like opposite.
What's how?
This is my x-axis. So opposite, hypotenuse, and adjacent. What is cos theta here?
That is fine. But how these two are related? Like
This is the like perpendicular. You can resolve it. Yeah. This is the triangle. Here we can define.
actually these are like Cartesian coordinates are these are the locations like in x y coordinate. For example, this is the location x and y. So now we in the Cartesian coordinate. How we are reaching here? This is I'm going from origin to X coordinate here and Y coordinate here. So this is my location. And this is in Cartesian coordinate. And the same location, if I want to see in the polar coordinate, then how can I do that? So I need to just write, draw a angle theta, and then radius r. Then you draw a circle. And then circle, then you can do all these things. Even if in that case, like you can take like x is equal to x sine theta also, but sine the circle is x sine theta, x sine theta, x cos theta. It also satisfies the circle, right?
Is it okay if he answer or he has to answer?
It's the origin there.
Yeah, you can answer some questions.
No, the triangle only we need. That you should.
Your sin theta, cos theta will depend on what the angle theta you define. You define with x axis, you get that to be cos theta. You define theta with respect to y axis, you get that to be sin theta.
So it doesn't matter.
What is the convention generally?
Yeah.
Convention is very clear. It has to be with x axis and the angle will rotate in the anti-clockwise direction.
Yes.
Alone.
That's
Not
what we
alone.
understand.
Therefore, with that you get this.
Yes, that is there. But we can take x is equal to sine theta also.
Yeah, we can.
Perfectly fine, then the theta has to be done with the
Yeah,
y
correct,
axis. Why change, define that convention?
Yeah, correct.
Then it becomes easy.
Yeah, that I am going to that, but that's in problem section. I was going to explain that. So, but due to time constraint, like I'm wrapping up here. But I have a couple of problems. If time is there, I can solve them.
10:52.
You want to take out 2 minutes or there?
Is-
You can take. Yeah. We started late. Yeah.
Yeah. As she pointed out, sorry, that will come under resolution of course, resolving, right? We are going to resolve the vectors. So, you know this, x, y direction.
So first thing is use the same diagram as you have used in the class. You use this one in the class, otherwise it's so confusing.
Okay.
If you have drawn a plane, you know the axis, right? So and the convention becomes very difficult.
Theta 1, here another force, this is F1, this is F2, is making axis with. So here, my first force, that is F1, is making angle with y-axis, right? And for F2, it is making with x-axis. F3, there is no component, like it's acting along the x-axis. How do you resolve this? Sorry? I want all the fx component and along y direction component as well as z direction. Exactly.
He said
So I'll try with f1x. Can I write it as minus f1 sine theta 1? Okay. And f1y, can I write it f1 cos theta 1? If you resolve this vector, f1. Why it is negative? Anyone?
Because it's along with negative x
Exactly.
direction.
If I resolve this,
I have to apply formula, if we get the formula saying that the actual theta is 180 minus theta 1. Yeah,
90 minus.
90 minus theta.
No, 180 minus
With
theta.
x
that's
Ah, with x-axis.
positive x.
Stick to F1 cos theta 1.
Yeah, and then come to
Theta
theta
1
1.
will actually should be
180 minus theta 1. So
90 plus theta. Make it
Yeah,
minus cos theta.
yeah. Exactly, sir.
Very well. I think there are lots of informed students in the class.
So, how about my f2x?
if you're successful, you will have questions like this. You're not successful, then nothing. This is how I will not care for you.
Why my both x and y component are negative in F2 case? Again, it's in third quadrant. Y is going downwards and x is going other direction. So likewise in F3, and write F3x. It is not making any angle. I can call it as 0. And sin 0 is 0, so there is no y component. So summation of all these right? Yeah. And one more problem I will give you for the homework. Here, it's a quite tricky problem. Yes, sir. You have to do. My x direction is this way.
Yeah, already told you the work. 15 hours.
My theta 3 is this direction. Yeah, there is no. Yeah. Try to solve this problem. Yeah. So concluding my lectures today, we got understanding about our learning cycles and outline of the courses and some expected dedication from you guys. And also we learned about basics of engineering mechanics, statics and dynamics. Something related to the force also we have covered. And force representation, that is polar and Cartesian coordinates. Also based on this problem, we learned about resolution of forces. So yeah, from next week, from next class, we'll be learning something about pre-body diagrams, some engineering examples on force balances and all. I hope I conveyed this topic to you. If you have any doubts, anytime, please free to ask.
Sir, you will tell us about exams, whether you will have to listen or you're not.
So yeah, we are working on it. We'll definitely will get back to you. Yeah, about schedules and all, we will get back to you. Yeah, thank you. Thank you.
We can all say next class.
Standard. One thing, quick thing.
Yes, sir.
This is a request. Please use vector symbols where it is a vector, make it a habit.
Okay.
Because these guys over time, and they forget. Then we again have to bang it to them. Wherever it is a vector, use the symbol, it's okay.
Thank you.
Otherwise, there is no addition.
Yeah, wherever it is. Please add that.
No, when you
Arrow.
do summation of it, epic you don't need to.
Ah.
You will go along itself.
Exactly. Because the magnitude on the left side, right side, you can.
So that we know where is magnitude and where is vector.
I agree.
That's coming at.
Very important.
That should come like some muscle memory. Should come.
Thank you. Thank you for the feedback.
The average is the F3 average is
Good summation.
Problem, right?
Ah,
Yeah. Good observation. This is towards this way.
I was thinking that.
And the other, whenever you draw that, you will have to articulate. Like you have, and you use F1, and you have, and you have drawn your X direction and Y direction. You should say that we take that and we draw the perpendicular from there, then this is that. If not, it looks too ambiguous.
Okay.
You will be doing it, don't worry, it's not a big issue, okay?
That is what we
No, one thing we should always clear is this should not be any dependent. This feedback is for us to know. Should not be dependent on anything, do not be dependent. That is first thing all of us.
But because I forgot all this. Suddenly I get like, how did that arrow come? Then I go back and think, God, this is how it
I think sometimes I use different color pencil also. The resultant code is
Use colors. So
Yeah.
I have some general points for sure.
Yeah.
You must speak a little louder.
Okay.
Okay?
Yeah.
And you tend to, your intonation keeps varying, doesn't reflect very confident.
Okay. Okay.
So that's, you should take care of that. When you give examples or when you ask questions to the students, let it be a little more very clear pointed. Yes. You should also let all the students respond. There's one student who seems to be asking more questions and answering. Let others also participate in the class. You can ask the student, okay.
Okay.
But this time let's back and something.
Yeah.
So let others also participate in the class. Writing is fine by and large. I was wondering whether +2 level they have learned trigonometry sufficiently.
Yes.
Yeah.
So there is no need. On topics such as, in physics, you have a little two-word discussion with the consultant. Come to your group of mechanics. They have something to say. Talk to, say, electrical people about electrical things. So they will have some information that will be very useful, like what Ramraj is saying about vectorial presentation. So what is it that they use it so much, they require it. Otherwise it's fine. Otherwise they must appear more confident.
Okay.
I think rest, I think by and large it's okay. I was just wondering, for physics people, are you for mathematics, for a three-dimensional representation, it's always good. You are now might get confused because you draw the X, Y, Z, and then you show projection and give an angle to that, and then otherwise explain X, Y plane and Y, Z plane. Is there a way of having a model for that?
And there are simulations.
Since I think the students will absorb it more clearly what you are referring.
Yes.
It will be good to have that outside the model. Because it's always difficult to present it maybe other 2D.
Yeah.
I think it is a.
We try to attempt.
Yeah, no. People who have already got used to it might be so, but I think the first students coming from +2 level, they should be able to appreciate your 3D presentation.
If not, at least a figure, much better.
No, but I think his idea is good. I mean, we'll have a four-dimensional model and then neatly project and show what X, Y coordinates are.
If you are doing it, then make it equal.
And also tell people that polar coordinates is as important as current. Give an example.
Give an example.
Especially when you have symmetry. Polar coordinates is going to be so useful and easy. So therefore, they should go. And in many cases, when we describe physical situations, we give R theta and then ask for X, Y, Z. So that conversion is so important.
Yeah.
In a physics problem. But it can be done. I mean, as such as that model will convert from one to another.
Initial, I think, help your students.
Yeah.
No.
Good, otherwise.
1 minute, I have one. Say,
More comprehensive.
yeah, one is you should appear more confident. You know the stuff. So, but many important things you don't write. This is a comment last time of the survey. Important things you will not write. For example, you give motivation or some reason, that should also be.
Okay.
That will just be erased. Only you write formulas and start. You speak many things, but important points, you make sure you write it down. That only you will get things in your head.
Okay.
So, and it's become very dry because of that. Because all I see is only some written formulas, the rest of stuff vanished. Because you didn't emphasize.
Okay.
Please motivate this lot. You need to really sit and think about examples to motivate every concept. This way if you teach, it's not going to be successful. This is not enough. There is no motivation in your class. It's
Okay.
just become another PU class. It's an engineering class where we need to relate to some physical stuff. Lucky you are saying physics. So easy to motivate, so easy to relate to physics. No physical objects around, so without motivation, I don't think this is correct way of teaching. Especially for stage students. It all came out as if it's just another tutorial class. Sorry, I'm just mentioning this because you need to really spend time. I know you have not prepared well on that part. You have to sit and think. Especially this is a problem with maths and science people. Over the years there is a problem. That is where they fail so many students. Because they don't motivate students to actually learn maths and science, which is essential for all engineers. It is a shame that actually students don't learn the software because teachers don't use the software. It just becomes another tutorial class. There's so much to relate. Everything is physics. And that is one thing. And do not ever encourage sloppy notation and sloppy answers. If you do, students will come with even worse problem. If there is a question like yes, why you should triangle, draw the triangle, show it, then and get solved. Yes, this is F theta. So if you do not do it, what is going to happen is they think you don't know, so they just keeping that question.
Okay.
Yeah, suppose the triangle question is very simple. Then you draw and explain why it is so. And do not use two different ways to represent your coordinates. You started with xy being at oblique angle.
I'm considering a plane.
I know,
Yeah.
but when you draw this, why you didn't use that? Here you change the notation to what generally we expect, right? That is, what you see is what is xy. Correct, there is nothing wrong, but this no, how do you expect me to use now? And this is the most familiar one, x and y are exactly at right angle. Everybody knows it. When you draw that, there is no oblique angle. Why xy is not at right angle triangles? So, and really speaking, please never encourage sloppy answers and sloppy notation. If you do that, that whole class, we have so many problems in our education right now because of this sloppiness. Yeah, so when there is a magnitude is magnitude, vector is vector, right? Fx is also vector actually. Fx is not a magnitude, right?
Yeah.
So then that is why you would add F3 there with the vector. Otherwise this cannot be written like this.
Correct.
No.
No.
That is correct.
I think he has a larger point. Let's take that larger point.
Yeah.
Where you have to represent vector as vector. This I will clarify for you what exactly. I think there's a larger point is very important. Be very careful about.
I think, these mathematics people, teach the vector calculus in the beginning. So the concept of vectors.
No, they.
But they are enough vectors.
What we thought actually is vectors is something that will include in the bridge course. They would have done sufficient amount of vectors in plus one. But just to put everything, every one of them on the same thing.
Yeah.
We are going to do some amount of vectors, resolution of vectors, and then addition of vectors, multiplication of vectors.
Yeah,
We will do it in the bridge course,
Yes.
and that's been listed in the bridge course.
Yeah. Good that.
This is only taking 4 into account.
What is the bridge course?
Bridge course is for 15 days. In fact, it is done before the actual classes.
We have come.
It is a mandatory course for the
Actually, it was supposed to start yesterday.
Yeah. Postponed by 1 month. Month later.
idea is simple. Idea of a fixed course is some that come with state boards, they have a different syllabus and school. CBSE, they come and then you have to use the common course all that. You have to find out.
ICSE.
Where are the necessary basics?
Yes.
IB.
Yes.
Start with it.
What you bring all of them, say never. All of them know about it. Correct. Okay. All of them know about some amount of. Everyone know about some amount of basic physics. Whatever subject, art, chemistry. All of them should have the same background so that you can take it. Otherwise, they must be. I can tell you that
We have basically included 4 topics in the English course from physics side. And there are some 5-6 topics from mathematics side that are included. Chemistry people also have given some 4-5 topics.
So the idea was we looked at ICSE, CBSE, some state board, definitely and SAT. And looked at syllabus and said that where we are starting, let's make it one uniform, level so that everybody is in the same page.
And also what is the requirement for the present course. So we need to bridge the
So
gap.
once that is done, I think we should also have same notes among ourselves. For example, something somebody
Initially,
starts.
I think we spoke with Ramraj and Radharam. And we spoke also with Nirupam. With Nirupam and also with
You joined.
with Mallikarjun.
This is one thing we should also know about anything that is happening, including. Each faculty will try.
Then the next.
Yeah, thank you.
Sharon might not come, so I should start.
So good teacher is going in search of food.
Okay. Good morning, everybody. I will be teaching you mathematics. So welcome to the course. And it's a pleasure to see all of you. And I'm really looking forward to the semester. And a little about myself. Okay. I'm Dr. Deepika Garg. And I'm a PhD from ISC Bangalore. And a specialization in mathematics. And my research focuses on developing numerical methods for solving complex mathematical problems arising in partial differential equations. And apart from my research, I have been teaching mathematics for several years. And I also have had the opportunity to work at the institutions in India, the UK and US for a couple of years. And I'm really excited to bring those expertise into our classroom. And before we begin, I would like to make one thing about mathematics, one thing very clear about mathematics. What do you think about mathematics? What mathematics is about? Numbers.
Language.
Language. What kind of language?
Language for science.
Science and engineering. Okay. Do you think like mathematics is about learning some formulas or some ways to solve the problems? Do you think like that?
Yes.
Okay, so this is one of the perception. Mathematics is not about this. It's a training of your mind, how to think logically. In other words, you have to develop your critical thinking and problem solving skills. And these are the skills that will benefit you throughout your career. And one more thing, many engineering students, I have come across many engineering students who feels like that mathematics is difficult. And it's a quite natural feeling, right? Whenever you start something new, it always, at the beginning, it always feels like challenges. You feel like it's a challenging problem. But my experience has taught me how to deal with the mathematics. Whenever you have a mathematical problem, you always break into simpler parts or like smaller parts or simpler parts, and then work on each simpler part.
And once you work on all the simpler part and then combine it, and the bigger problem is easier to solve. So this is the way of doing mathematics. Therefore, I would like to encourage, please don't afraid from mathematics. Work on the problems. Don't hesitate to make mistakes.
I'll get marks for that.
Yes, you will get marks for that.
If you get marks, if you learn from the mistake.
Yes, yes. And if you have any doubt, please come to me. I will happy to solve that. Okay. Now let us see what we are going to learn in this course. So this is Mathematics 1. So it has two parts, right? Calculus and linear algebra. And this is the basic, very important foundational course for engineering mathematics. And this course is designed not to just pass the examination. This course will prepare you for the engineering, data science, programming, and more advanced course that you will learn later. And now we have these two topics, right? Calculus. Why we need calculus and why we need linear algebra. So we should know the goal, why we are learning calculus and linear algebra. The goal of the calculus is optimization. Optimization means we need to find the best possible solution. And in engineering, you might have heard or saying like we need to find the maximize the profit or maximize the lift, right? Maximize the lift or minimize the drag or minimize the cost. What else? Minimize the energy consumption, right? So these are the questions we are going to answer here. For that we need some tools. What kind of tools we need? So here I'm going to write some tools, and these tools are interconnected. Here we'll start with limits and continuity. Limits and continuity. Once you understand that, we will have differentiation. And then applications of differentiation, we will have mean value theorem. It's kind of application in the sense we will know more about differentiation, what differentiation is about. Mean value theorem, and then Taylor's approximations. Taylor's approximations, and then the optimization. It's kind of application of derivative. Applications of derivatives, and we have already done maxima and minima. Maxima and minima, in mathematics we call it as maxima and minima, and in engineering wherever you go, maximize the profit or anything, right? Similar, same things. And as I earlier told, whenever we start something new, we always break the bigger problem into the smaller parts, right? So that we can visualize it and we can understand properly. So the same thing, our goal is optimization. But engineering problems are in one higher dimension, right? So here, first we will introduce this optimization in single variable so that we can visualize it properly and understood the concept better. So we will do all these things in single variable. Single variable. Now, since this is only one variable functions or these concepts in one variable, now we need to, because for example we need to design the aircraft or design a bridge or design a mobile app. So these are multi-dimensional system, right? These are a multi-dimensional system. So we need to do all these things in multi The idea remains the same, idea is same, but the only thing we have to extend this idea to the multi-dimension. The same thing then we will learn in multi-dimension. Therefore, I am going to write multivariable functions or system, and we are going to learn the same things. I'm going to write multivariable topics here, the same. First we will start with limits.
So by multivariable functions, domain is multivariable or codomain is multivariable?
Okay, multivariable, it's like, okay, the way I said, multivariable function, first we will start with, I'm going to write R3 to R. First, okay, so right now, until n plus 2, you know this much only, right? So multi-dimension function means kind of this, not R. At the first place these things. So first in between we will introduce this so that our domain is R3 and the valued function. We are going to study the scalar valued function. Once we understood it, then we will. Okay. Limits and continuity. And here we are differentiation. And here first we will talk about partial derivatives. And then theorem, Taylor's theorem, all these things will be there in multi-dimension. Mean value theorem, approximation. And then we will have, instead of differentiation would be there, but we will also talk about directional derivatives. Directional derivatives, and here in the one dimension, differentiation means existence of a tangent line. The line becomes here plane. So we will talk about tangent planes. Like I'm writing the same thing in a again the same thing. So these are the things we are going to learn in the multi-dimension.
There is no integration
Where?
in this.
At least here in the calculus we don't have, but in the vector calculus we will have some applications.
So integral theorems are.
Integral theorems, yes. And the same thing like application of derivatives. Application of derivatives. In mathematics, single variable we call it as maxima and minima. Here we just use one word, extremum or something like that. Yes. And now and the third unit we have here is about vector calculus. In vector calculus, in electrical okay, so these are in second unit itself. No, it's not about that unit. I'm just saying in a calculus only I'm making it to 3 parts. So another we will going to learn vector calculus. In vector calculus we are going to learn gradients, divergence, and then applications of integral calculus, like divergence theorems, line integral, all these applications of integral calculus in vector calculus. And this is about calculus. Now we'll talk about linear algebra. Why we need linear algebra? In modern language, in modern engineering, we will have thousands of variables, right? To deal with such a high dimensional efficient data, we need another tool, that is linear algebra. This high dimensional data, then there we need tools for linear algebra. And for linear algebra, we will start with vectors, matrices, and then system of equations, and then we will move on to vector spaces, then linear transformation, and the third topic, I'm talking about the vast topic, and there in this also we will have small different subdivisions. I'm talking about the vast topics here, bigger topic. And the third and the last one is eigen decomposition. Eigen decomposition. We will start with the symmetric matrix, then we relax the square matrix, then we relax the square matrix, then we will come to in square matrix also we will have two divisions, square matrix kind of symmetric where we have all the linearly independent matrix. Then we will go to the Jordan decomposition when we don't have all the linearly independent matrix vectors. Then once we relax that also, we will go to the, where we will go? Symmetric singular value decomposition, when we have the rectangular matrix. So this is singular value decomposition. Singular value decomposition. And these are the topics, these are very, very important in modern scientific computing, machine learning and data science. These are the main tools, and even I am also using in my research all these. And now let us talk about, these are the topics we are going to learn. Now we will have 15 weeks. We will have 15 weeks, and each week we will have 3 lectures. 15 weeks, that means we have 45 lectures. And how we need to divide? We need to divide these 45 lectures between these topics. So what we are going to do, these things you have already learnt in 10+2, right? So we will revisit it, but we still need it, and we are going to use our 9 lectures here in single variable, and then 18 lecture all together, extension of the single variable to multivariable, and then vector calculus. We need 18 lectures here, and then linear algebra. This is like 2 different words, so we need 18 lectures here. So all together we will have 45 lectures, and in each week we will have 1 tutorial also. So 15 tutorials also we have. Fine? Okay. Now learn these topics. Just give you an idea. For example, today we are going to learn limit and continuity. Today is my, just let us suppose today is my first lecture. So how we are going in this week wise? So what I will do, I will start with the topic. We will we will focus on the concepts. This is a small word, concepts, but it has a bigger and different meanings, right, for everybody. That I will explain later what you mean by concept, but here we will focus on the concepts. Concepts in the lecture. Once you understood the concept fully, for example, if I'm talking about, I know limit and continuity, means you know each and everything about limits and continuity. Once you understood that, then what we are going to do? We are going to apply these problems to the applications. Okay? So the next step is, once we understood the concept, then we are going to do applications based on the concept. It depends upon, for example, I'm talking about limits and continuity. It's not about we are just going to do the application in real world application. We will also need these limits and continuity for differentiation also. We will do both. We will apply these concept to the applications. And once we do these things, okay, so when we introduce the concept, mainly I will be working, like I'll show you how to do these things. And once you understood that, so we will do the applications. Then the application, like I will do that, but you will also participate that, how to do these things, because you have already understood the concept, right? Then only we are doing. Okay, then we will do the applications. Now you understood the concept, you understood how to do the applications. Now it's your turn. You have to do it yourself. It's called problem sets. You have to do problem sets. Fine. Now you understood the concept. We have done the applications. You have done the problem sets also. But there might be some students who might not understood the concept properly, right? Or they didn't understand how to do the applications. Or there might be some students who knew the concepts also. They have also done the applications independently also. But still we have one tutorial, right? In that, we will discuss all these things. For example, some students know everything. Then we will see how we can solve the problem sets in a different way. Is there only one way to solve this problem, or there are any different ways also? Fine. Or there are some students who has like difficulty in the concept also. Then we can discuss all these things in the tutorials. Or if there are some like 10 questions we have, 8 are already done by the students, but still there are 2 right left. Then we can discuss all these things in the tutorials. So tut is also over, right? So I'm fine until now. Now is it done? Did I know like I'm able to get like you understood this concept? Is it okay, like already you know this concept? No, right? So I have to make more arrangements so that I should know you already knew or not, like you already got it or not. So in that case, I will arrange one quiz in the beginning of next week. Okay, in that maybe it's one question or 2. And I have, like in that time I'll get to know you have understood the concept or not. If you have understood, it's fine. You have some difficulties, like in student they have some difficulty. In that case, what I will do, I will try to change my teaching method. Okay.
Quiz, what is the syllabus and how many marks quiz and what is the syllabus?
What kind of?
And you said quiz.
Quiz.
Quiz. What is
I'm just talking about the concept, limits and continuity. This is the topic for the last week, right? So I'm just talking about this limits and continuity, my first topic. So the questions will be on this only.
Oh.
Okay. So I I have to see you have understood or not. If you are understood well enough, I'll go ahead with that. If you don't, then I have to change my teaching methods, or I have to see how I can make you feel better in the limit and continuity. This is the main aim of the quiz, okay? Because all these concepts are interconnected. If you have the difficulty here only, then it's not a good idea to go at the end.
Yes.
So that is the main thing. So this is the quiz. So I have talked about these things. What I left is fine, I think. Okay, now I'll talk about the books. So the books we have, it's for the calculus, we have James Stewart. James Stewart. So for me, easier is if I already know some there or what is not there or what is not there. Okay, I understood syllabus.
Course becomes to already we have 2 subjects in the full course.
Yes.
Calculus is there, linear algebra is there, so it becomes 2 to use if you
But
start.
then it's more of differential calculus.
In limit and continuity, what we are dealing with? What things we are dealing with?
Limits and then continuity.
Like limit.
Is this a function?
Okay, that's what I'm saying. It's a part of a graph which is a which is represent some function which is not a representative function. That's what I'm trying to say. I will define it later, but before that you should say something about that, then only we will define it.
I see a circle there. I see an ellipse. You see an ellipse.
Okay, ellipse. Okay, fine. So do you think it's a, do you think
With respect to x.
okay. Because this is symmetric. So do you think these are functions?
No. I don't know.
Don't know. Okay.
If that's the thing, just write one place, just
Okay.
see, there is a nice student also.
So we have 2 sets, right? We have 2 sets. 2 sets means where the values of x are coming and from where the values of y are coming. So we have 2 sets. F from x. So these are x and these are y. So we will have some points here, some members of this set. 1, 2, 3, 4. Okay. So you have already previously learnt a function is a rule which associates each element of x and with the unique value of y. So function, I'm writing in English, then we will understand what is the meaning of this sentence. Function is a rule which associates each, I'm underlining it, each value of x with the unique value of y. This is not y. Can you now tell how do you define? Like I have written in English. Now can you represent in mathematically? You have some x, you have y. It has numbers. It has numbers. Don't look at there. Just look at here. How do you define function? Each value, each means every member is associated with y. It has to go each value here. It can go here, no problem. It can go here, no problem. Is there any problem?
Yes,
What?
it is not associated. Two x values are associated to one y value and they are not.
Where did I say 2x values cannot associate with y? I said each value of x associate with the unique value of y. Okay, so that's the main thing. So it's a function, right? So why we cannot, so here what I'm trying to say, I'm just talking about temperature. I'm talking about temperature. At one point, at the same point, can you have two values? If this is a temperature function, can you have two values at the same point? For example,
At the same time.
okay, T0, that is good. T0 and T0. Can you have two different values? No.
So unique over here means one value, not
At one point on one x, you should not have two values. Like this is a temperature function, right?
what is the meaning of unique? Unique is unique.
Unique means you have only one value, only one. Unique. Unique means you are unique.
All of the x can be pointing to only one value.
I'm trying to explain. So each value means you should cover all these points. Fine? This is the meaning of each. And now we are saying associate with the unique value of y. Unique value of associate with the unique value of y means here you cannot say at t naught should have two values. It is not the rule. And why? Because whenever we are defining or defining mathematics, it should be physically relevant, right? That's why this mathematics comes in the picture. So it's like these are some functions I'm taking, but these are the dummy functions. But whenever you are using in physics or aerospace, these are some temperature or some lift or drag, these are some real functions, right? So this should be physically relevant. Or at one point, do you have two values? At one temperature time, can you have two values? No, right? That's why, for example, if I'm taking x0, this is x1, x2, x3, this is y1, y2, y3, y4, y5. So at x0, t at x0, you cannot have like y1, y2. You cannot have like this. You cannot have these things. Fine? You cannot have these things. But, okay, this is fine. But you can have, now first come to this example. You have different time, but for different time you can have the same temperature, right? So this is this, and but you have to cover all these points. You have to cover all these points, but you can left these some points, not a big deal. Fine. Now we come to these points. Now tell me about this. Do you think this is a function?
Yeah.
Still, these are your values. At this, how many y values are there? Two.
But if I come down to this one, think of y is equal to root x. You get a curve like this. Isn't it?
No, that is just a representation, but this is,
But I'm just asking.
yes, that's what I'm trying to say.
No, wait.
That's why I took this example. I know what you have, what you doubt you have, that's why I took this example. here I'm saying x to y. No, not x. Okay, I'm not saying it that. F from R to R. R is a real set of real numbers. So all these here, a set of real numbers. Ramraj, do you have anything with the R? Real number. These are set of real numbers. Okay. Minus infinity to infinity. This is 0. This is infinity, minus infinity. In all the numbers, we have integers, rational, irrationals, every number, whatever you think of, these are the real numbers. But minus infinity and infinity are not included. These are not the numbers. Whenever you are talking about numbers, that means you are talking about the finite quantity.
That's an open bracket.
That's why I have written the open bracket. Fine. Number means it's a finite quantity. Okay, so I'm writing it as x square. Oh, no. No, it was, okay, y square is equal to x. Y square x is equal to x. So this is just a representation. This is not a graph, right? Graph I have already, this is just a graph. This is not a function. Function means it should satisfy all these criteria. What we have to make it a function.
I have to say x is equal to y square.
Yeah, this is x. Just listen. So this is y square is equal to x. Fine. Now in order to make it a function, because here for each value, okay, we have two values, right? So we can just simplify it. If we just restrict our codomain, can you do that?
Only for
Oh, okay. So if y is only positive, then the negative part is on, right? Now it represents a function. Okay. Similar goes to circle also.
Yes.
So circle, at each point you will have two values. So this is not a graph of some function. In order to make a graph of some function, you have to take semicircle. Fine. So this is the function. Fine. Now let's talk about, should we go further, like about limits and continuity? Okay.
Madam, next week.
How much time is there?
If you ask that question, that's the answer we get.
Okay.
Don't ask that question. You decide whether to continue.
Okay. So what do you think? Do you want to learn limits and continuity or just stop here?
Stop. Tomorrow, ma'am. Thank you.
Okay, fine. Oh, sorry. Now I'm just, okay. I have already told you what mathematics is about. These are my expectation. Main expectation is just learn the mathematics by heart. By heart means it is not about the examination. You have to know what mathematics is about. So by the end of this course, I'm thinking you will not only learn about these formulas, you will learn how to think logically, how to analyze the problems, or how to solve the real world problems using mathematics. If you do that, if you can do that, I'll be more than happy. And what else I can say? So please do. Okay, so mathematics is, you cannot like learn the way you can do other subject, right? Here you have some intuition. One more thing I'm telling about mathematics. For example, even in research also. So for example, if we think like this idea may work or something is there, even if you have some intuition, but still you have to work it out. Because at the end, we think these things may work, but once you do that, then only you'll get to know. The mathematics is like that. So more you do, you more get the idea. I'm not saying just do the calculation. Sometimes I'm saying like factorize x square minus 4x plus 4 is equal to do more work. You will get like, you will know how to do this. I'm not saying that. Just focus on the ideas, how many ideas we are going to work. Ideas are important, and once you get the idea, and then it's your practice. That's all. Thank you.
Anybody wants to say something?
Yeah, why should you restrict it to art? You can just leave it to art.
No, because to make it a function, we need, here we have
That discussion I can have it later.
okay.
You tell that also. Anybody, you don't have to tell them you can. Actually, it's okay.
Okay.
It should be R plus to R plus. So, negative R it cannot be so.
Okay, yeah. And even if a root x it doesn't even define. Yeah. Thank you.
So,
Okay.
one thing actually, once I mentioned, it will, that much detail, which students it will go overhead and they will know. So, for example, multivariate Taylor series, you can just maybe reduce it a little bit, say that there are these topics are there, we will learn one by one. You
Okay.
spend too much time on the multivariable thing actually, so you can cut down that one. And you have given motivation telling why you wanted to teach something, you are trying to convince students a lot that why it's good, that is good. But you also take control and saying that you are going to learn. Okay, so that is going to be useful. So do not ask, in the first class at least don't start with too many questions. Because for example, what is a function? I am sure 90% of about it. Okay, they have used what is sin x is a function, they know. What is a function? I don't know whether it's defined in PU level first of all. So maybe just don't ask too many questions in the first class at least. You try to generate interest, and if it's too many questions, many people will be out of that. But good thing is you are actually, for example, optimization is a good, what do you call, landing point, and that is used very well. You explain that very nicely. But same thing you do for linear algebra. I know you have to spend some time on landing that way. You said higher dimensional, computation needs linear algebra.
Yeah.
No, you mentioned that handling. I'm repeating what you told. But that doesn't land as well as optimization being, because you have thought through very well.
The linear algebra, the complexity involved in linear algebra, why computer science students need 3D matrix. So that point will generate more interest.
Okay.
It's not that simple matrix and determinants and all that. 3D matrix writing itself is a difficult one. How to represent a 3D matrix?
Okay, sir.
Deepika, your presentation is good, your writing is good, no issue. But you tend to say more than what you write, sometimes students may not comprehend.
Okay.
You said many more things. I think students should not do it. Otherwise, I think that you can live with. That's otherwise no major issue. I would say 2-3 points which are bothering me. One is about your total load for the students. If all of you are looking at 45, that is 4 hours, 3 hours of lecture, 1 hour of tutorial, and for all subjects, and then 2 hours of laboratory work for the 4 labs that you're going to have.
Sir,
Total load for the students.
So we have counted all the hours actually. It is coming out to 28 or 29 maybe.
So make sure that you don't overload the students.
No. That's why I was worried when Prashant was mentioning interactive sessions only we can count, which is 28 or 29 hours. 4 major courses which has lab included.
That's one issue. That's fine. I'll also measure.
Yes, sir.
The next point I want to tell you, I think it's something I want to tell all the teachers. To make the lectures more interesting, you should draw some anecdotes, historical references, it's something like, these are all things which make classes very interesting. Otherwise I think it is strictly technical sometimes is not going to keep the attention of the student. So I think it can be done in many subjects. It can be done chemistry, physics, mathematics, the engineering, all of them. So like in aerospace engineering, I used to talk of Tsiolkovsky's life.
Okay, okay.
He said, mention something. It might take 30 seconds, but then it
Say
will add to the value. I think that you should practice it in a general way. Evaluation process 70%, 30% is it consistent with this? That is, she says 10% for midterm, 20%.
Yesterday we were discussing that. So that we have finalized, but somewhere you have to converge on
So
that one.
I think if I understood that properly, out of that 30%,
See,
10 is here and 20
so 1:2. That's what she said. That's what she said. But I don't mind that bit, little flexibility amongst the like to tell the story. Then there is some books you cite some 3. Make sure they have common notations.
Okay.
So now
This is where, in my lifetime, we had Russian professors teaching Russian, very different notations. I used to have a lot of problems with that. So make sure that the notations are common, or at least you define, this is what we are going to say. You said this book, you said James Stewart or something, right? And then...
Thomas.
So luckily, sir, in this case, what happened, linear algebra is quite distinct. So notation, so luckily there is no overlapping much.
Yeah, that's all. I want common notations. Actually, at the end of the whole thing, this is not on your lecture. My concept, I am confused. I said, unit of function should have a unique value.
Yes, sir. The function, the relation can have, but function doesn't have.
So if x is a function of y, is y a function of x?
No, not necessarily.
It's not about that it's f is a function of y as a function of x. We just, like it's a just representation. It's a just...
No, sir,
If you have a uniqueness part of it, x is a function.
No, even
So
then-
y is a function of x is correct. But x is not a function of x.
So that is again, okay, sir, I'll tell you, sir, I'll tell you. So, okay, so this is, this is the definition of function. When you are saying f is a function of y or y is a function of x, then we have to also think about what kind of we have. If these are like, then we have another 2 things, 1 and on 2. We have to define its injectivity and surjectivity. Once we have, then we can define the inverse. Once the inverse exists, then we say x is a function of y is a function of x. Then we can say, otherwise we cannot say anything.
there is a condition one.
Yes, that's what I'm saying.
I think the word unique is misleading over there. It should be one.
Unique is one.
Okay.
Unique means distinction. All of this x can have the same value of y. Yes. So when you say unique, it means that whatever x has, y cannot be mapped to 2 values of the x over here. Because then it is not unique. Right?
In mathematics, we call it unique, or like in the same way, if you can, I can also say in your...
Here is a point that what is...
The word is like slightly misleading.
The image is unique if you say, as if the image cannot be same for 2 different. That way also consider. One and only one is the best one.
Okay, one and only one. In mathematics, we call it as unique. Unique. That's what I'm trying to. Okay, sir. Yes, it's fine. The main thing is I wanted to make it clear, so I explain it right. What is the meaning of uniqueness? I said right. What is the meaning of uniqueness? That yes.
I'm just telling like because
But it is a common thing to use that. Correct.
And also many textbooks uses that.
Yes, unique is used.
Uniqueness is something I had not learned it. I always do in some one dependent on that.
So that is why do not assume that people will know this.
Uniqueness is something.
Hardly anybody learns it.
Okay. Next time onwards, I'll say one and only
All
one.
of them are functions.
yeah.
My answer would be all of them are functions.
All of us.
No, one of the reasons. All of you, So it's easy to.
Not suggestion, but clarification. Majority of lecture time, we were actually looking at that side.
Ah,
Was there any reason?
I wanted to
specifically,
comment.
or was it intentional or
intention,
What
unintentional.
happens, I'll tell you.
You are always focusing on.
No. Still focus on because they are going to respond to you. But you should also be careful who is not listening and all. It is not a lecture.
I tell you, if you have your guide, for example.
That is when you actually require multivariable. And your simple, say, slope now becomes a plane. That example was also very nice. But if you can connect it actually with this, students may relate it. Oh, there is actually a now. So, okay. That has been. Now, optics comes because of application part. Okay. Where I say that how is this connected to things, for example, if you're.
That is one direction, and obviously this is what has driven us also saying that wing of an aircraft. It's an optimization problem. We should have many classical solutions. Use a nonlinear optimization problem or whatever you can do. But what has happened is all those routines are actually